Hi, this is Siddiqui Brown with group number 5 in EGN 4952C, or Engineering Design 2, and this is our group's showcase presentation. In this presentation, the group will be giving a fairly general overview of our senior design project and the application we developed on the Magic Leap platform. At the end of the presentation, we provided a link to a video demonstration of the application in action, and if there are any questions about our project, all of our information is provided here, and you can feel free to reach out to any of the group members. So without further ado, let's jump right into it. So our project was provided to us by a company called TRAZER that develops new technology in the health and fitness field. Their current frontline product is a motion-sensing camera-like sensor device that works in conjunction with TRAZER-developed Unity applications. These applications enable users to train their body and mind while also gathering data for performance analytics. TRAZER's current console is fairly large, so not really as portable as they would like. This led to the idea of developing TRAZER-like applications on the Magic Leap platform to show that the integration of Magic Leap could enhance the delivery of the current simulation provided through a TV screen. To achieve this, the team has developed a Unity application that has been deployed on the Magic Leap 1 augmented reality headset. This application allows the user to run a virtual simulation encompassing two different activities. The first activity is a reaction testing activity that mimics the functionality of the Dynavision vision and reaction training system. The second activity is a more traditional port of TRAZER's flanker test. This will show that the Magic Leap platform is suitable for existing TRAZER activities. The data gathered from these two activities will be logged in the team's AWS MySQL database for us to perform our own analysis as TRAZER would with their equipment.
Hi, this is Ryan Foster, and I'm going to quickly go over more details on the activities that were developed for our application. The first application is a reaction testing application that will function in a manner similar to the Dynavision and reaction training system by TRAZER. The app will virtually simulate a board with 40 different interactable buttons that will light up in a random sequence. The user will be prompted to touch these buttons with their hands as soon as they appear on the board, thus allowing us to determine a reaction time between the button becoming visible and the user reacting and pressing that button. The reaction times are stored locally in milliseconds on the Magic Leap headset via a C# script array and then uploaded to the team's AWS MySQL database. This application is meant to serve as a basic introduction to the Magic Leap platform and how fitness and health-oriented applications could be used and implemented in an augmented reality setting. The second application that the team worked on is a more traditional port of the TRAZER flanker test, which requires a user to move laterally to their right or left depending on a given prompt from the application. The team built a partial version of this application as an implementation demo last semester, and we have now expanded the application to allow for greater data collection for our AWS database. Whereas the reaction testing application is focused on reaction time, the flanker application looks to track other metrics such as the user's velocity using the Magic Leap's own spatial tracking hardware. Again, these values will be stored locally on the device and then uploaded to our database when the activity is complete.
In this slide, it shows the functional design flowchart for our application. After launching the application, the user will be promoted to lock in their play area before being taken to the page that collects the user demographic information. The user is then will be able to make a selection on which activity they want to carry out, either the Dynaboard or the flanker. Upon completion of either activity, the user can review their performance data and select whether or not they would like to run the activity again.
This is group number 5 in EGN 4952C Engineering Design 2, and this is our live demonstration for our design project, okay? In the headset currently is team member Michael Vieta. He will be running the application. Also present is Siddiqui Brown, Ryan Foster, and myself, Michael Resendez, behind the camera. Abdul Zarli is currently quarantining right now, so he's not going to be able to be here, but we still think this is a great opportunity to showcase what we've accomplished these past few semesters and what our application entails. So Mike is wearing the headset. He is running the team application. He is going to confirm his play area with 2 thumbs up. Now he's just going to fill in a few demographic questions for us for our own analysis later with the team database. And then for the purpose of this video, we are only going to run the flanker activity just to showcase some of the features of that specific activity. So Mike confirms that selection, and now he's in the flanker activity. He's going to start it up by grabbing this cube. He's going to return to start, 2 thumbs up, and then he's going to follow the prompt that he is given. So again, just as a general overview, the Magic Leap 1 headset is using the flanker activity to track several important metrics for us. It is tracking the time difference between when Mike gives his thumbs up to when he grabs the correct cube. It is tracking the distance that he covers between those 2 points. And then it is using those values to determine other important performance metrics like velocity. And again, this is just our team's way of emulating the work that TRAZER has done with the sensor equipment that they have. We're attempting to replicate that on the Magic Leap headset. And really, the team believes that this activity is a perfect example of the potential that Magic Leap and AR technology has for both TRAZER and the fitness industry. So as we explained previously, current TRAZER software has to be run with specific sensor equipment that has to be set up and tested, whereas this team's application can run an activity very similar to the traditional TRAZER flanker test, but with just the Magic Leap 1 headset and almost any environment. And we think that's going to have a huge impact for both how TRAZER software is delivered and how users experience it. So Mike just completed the flanker test. He's just looking at a brief report of some of his performance metrics from the activity, and now he's going to get out of the application, and we're going to connect his headset now to our computer over here, and it's going to allow us to upload his performance data to the team database. All right, so Siddiqui is plugging him in right here. We're going to use the Magic Leap the Lab device bridge to pull the SQL scripts that were generated by the application. We're going to pull those directly off of the headset to our computer, and then we are going to insert those scripts into this MySQL Workbench tool. And this is just going to allow us to manually insert this data to the AWS MySQL database. So that is what Siddiqui is doing here. And then he's just going to confirm that it was uploaded correctly. We're going to actually pull up the entire table, and we can see all the data that we've collected so far. And you can see that final entry. That was Mike Vieda's performance in the flanker activity. You can see, again, his demographic information. You can see the prompts he was given, the velocity that he had for each of those iterations, the time, distance, all those good metrics.
Hello everyone, this is Michael Vieda, and I will be explaining the general discussion slide. So on the left side you'll see here is the project objectives, and we'll go one by one and explain them. The first thing we mainly were focusing on was proving that the Magic Leap headset that we had was capable of being an AV source for the TRAZER technology. This was very important for us, and this is the foundation of our project. We also want to show that the integration of Magic Leap has the ability to enhance the delivery of the current simulation provided through a TV screen. It makes it much easier for other people to be able to see what's going on, especially with the fact that we have the Magic Leap headset. And we also wanted to prove that the Magic Leap AR headset was capable of handling the Unity graphics, which is the main engine that we use, Unity, that already existed on the TRAZER platform. And we also had a few things that we wanted to discuss on this side. Was the core project objectives were accomplished by the team. The team knowledge of Magic Leap, Unity, and C# grew immensely over the course of the project. It definitely was a lot of knowledge and a lot of information that we didn't have too much experience with, and I'm glad that we were able to get so much out of it. We also overcame a lot of challenges over the past two semesters. There was a lot of things we had to learn, and especially when we did learn how to be an agile team when it comes to the project development aspect. And several aspects and ideas for the team and/or TRAZER to expand upon in the future. So there's definitely some things here that I hope TRAZER can take away from, and definitely some information that we learned a lot of, and we're very grateful for it.